Hey guys, welcome to this chemistry video on periodic trends. So this one, periodic trends, is a really simple concept, really, if you just understand two things really well. If you understand those two things really well, you can use a periodic table to predict now which atom is going to be bigger, which ion is going to be bigger, which one will have bigger ionization energy or greater ionization energy or less. There's a whole lot of stuff that you can figure out by just knowing the two simple trends in the periodic table. And so here's how the periodic table is arranged. As we go across from left to right, it's called a period. And those periods track with energy levels. So every single atom, and I just wrote the energy levels in there, every single atom in here, along here from left to right, it doesn't go past energy level number 4. So for example, if this is the nucleus of that atom, right, it's going to have 1, 2, 3, let's say 4. So what we're saying is that the electrons can go all the way out to this outer limit, but they will never go to the next one, which would be like 5, right? So all of the atoms in this entire period can go up to energy level number 4, right? And they do. They all have electrons in energy level number 4. So all of them will be at least that size. We measure the size of the atom. We're looking at how far it is from the nucleus to the outer limits of the electrons. But so here's what happens. So if all of the atoms in here cannot have their electrons go past energy level number 4, here's what happens. As we go across left to right, we keep adding another positive every time. And so what does that do? Well, every time you add another positive, it bulks up the charges here in the middle of the atom, in the nucleus. And so what's keeping the electrons here is the attraction of these positive charges on them. And so if they can't go past energy level number 4, it means they can't get any further out. And if they keep adding more and more positive charges, what's going to happen is that's going to attract those electrons more. It's going to pull on them harder, which is going to do a lot of things. If it pulls on them harder, it's going to make the atom smaller, right? If it pulls on them harder, it's going to increase the ionization energy, because ionization energy is the energy needed to remove electrons. So we could say energy to remove electrons. Right? That's ionization. What about electronegativity? Well, it's also going to increase the electronegativity, because electronegativity, as we go from left to right, is going to be the atom's ability to attract electrons. So we could say this is attraction for electrons, right? And so so all you got to know with periodic trends is what happens as you go across a period. And here's what happens. All of the electrons are within one limited energy level. None of these atoms can go past energy level number 4, which means they can't go past here. But every single progressive atom has more and more positive charges. And so that pulls on those electrons harder. And when you pull on those electrons harder, you make the atom smaller. So the atomic radius, or radius is another way of saying the size of the atom. So the size of the atom gets smaller as you go from left to right. And the ability to attract electrons gets greater as you go from left to right. And the energy to remove electrons gets greater, right? Because it's pulling on them harder. So germanium with 32 positives as opposed to Ti right here. I think it's titanium. Anyways, is going to pull on it harder, right? It's going to pull on those electrons way harder. But both of these have all of their electrons out to energy level number 4. And so this one, with 10 more positive charges, is going to be able to give that much more pull on those electrons. So this is going to be harder to pull electrons away from there, meaning that the ionization energy is increased. It's going to attract electrons to itself better, meaning the electronegativity has increased. And it's going to be smaller because it's simply pulling on all these things harder. So that's the trend from left to right. Now let's look at the trend from the top to the bottom. Now we talked about how this is the energy levels right here, right? Now, when I go down, every single time I go down a section here in the group. So if I go, so these are the groups right here. Every time I go down, you see what happens? I'm adding another energy level. So if this is my atom, right, I'm right here. As soon as I go down here, I'm adding energy level number 2. So what's that going to do to the size? Well, it's going to make the thing way bigger. So every time you go down, that atom is going to increase by a lot because it's going to add a whole nother energy level. Now, what about its ionization energy? Well, every time you go down, the electron gets way further away from this nucleus. And so that sheer distance makes it so that it's easier to pluck these away. So when you go down, the ionization energy decreases because it's easier to pull them away the further they are away from the nucleus. And the electronegativity also decreases because it attracts electrons less. All right, so 2 more things I'd like to sort of cover in that come up here. And the other one is ion size. So what is an ion? So first of all, we need to define what an ion is. So an ion is when an atom gains or loses electrons, right? So gains or loses electrons. Now, so this is pretty simple. These trends are still going to work with ion size, but there's going to be one little difference. And that has to do with the atom gaining or losing electrons. So let's take a look at magnesium right here. So if I take a look at magnesium, magnesium has energy level number 1, 2, and 3. So this is magnesium has energy level number 1, energy level number 2, energy level number 3. Its electron configuration is 1s2, 2s2, 2p6, 3s2. Okay, so it has a full energy level number 2. In order to have a full energy level, you have to have in the outer energy level a total of 8. Notice we have 2 electrons here and 6 electrons here. If you don't understand this electron configuration thing, watch my previous video on electron configurations and you'll get it. And so you have 2 electrons in energy level number 3. Now atoms want to have a full outer energy level. So 2 is full. But 3, in order to fill 3, I would need a 3s2 and a 3p6. So I would need to add a whole 6 electrons into here. So magnesium has 2 options. It can either try to bring on 6 electrons, or it can just say, I'm going to get rid of those 2 electrons. I'm going to lose all the electrons in the outer energy level. So if this is energy level number 1, this is energy level number 2, this is energy level number 3, you see what happens if magnesium loses 2 electrons or becomes positive 2 charged. Here's what's going to happen. It has 12 positive charges. If it loses 2 electrons, it's going to have 10 negative charges, right? So that means we have an overall positive 2 net after we've lost 2. And it loses 2 because it doesn't want to try to gain 6. It has to have a full outer energy level, meaning it has to have a 2 and a 6. It has to have 8 total in the outer energy level. Now watch this. When this loses those 2 electrons, it loses that whole outer energy level. So the size of magnesium just went from this to this. So if you were asked which one is bigger, a magnesium ion or a magnesium atom, well, the ion has lost a whole energy level. So it's going to be way smaller. So the trend with ion size is positive equals smaller, right? But what about negative? Look over here at chlorine, chlorine right here. Let's look at chlorine. Well, chlorine has an electron configuration of 1s2, 2s2, 2p6, 3s2, 3p5, right? So in order to have a full 3, all it needs to do is add 1 electron here, so it ends up with the 3p6. And that's pretty easy to do. So atoms are going to do whatever's easy. If it's easiest to lose them to get 8, then it'll do that. If it's easiest to gain them to get 8, then it'll do that. So in this case, chlorine is going to gain an electron. So it'll have 17 positive protons and 18 negative electrons. So that's a net of -1. But see what happened is I added more electrons to the outer shell here, and that's going to make it bigger. So negative, if your ion, which is meaning it gains or loses electrons to have a full outer energy level, if it gets negative charge, it's going to be bigger. Okay, so then the trend goes like this. As you go across here, it's the same trend. They're going to get smaller as they go across, because for the same reason they got smaller before, the energy level stays the same, and the positive charges increase. So there are more and more positive charges as we go, which pulls harder on those electrons. But when we get to about right here, you see, look at, here's our nonmetals for sure. We have this stair-step kind of thing right here, right? And this stair-step thing, these are metalloids right here, so that means they can do either. They can become positive or negative. And all of these in here are what we call nonmetals, which means all of these will assume negative charges. So if you look at this, carbon is often going to assume a -4 charge, right? So as soon as you get to carbon, that thing's going to get huge, because it's going to bring on 4 new electrons, right? Because it has 4 electrons in its outer shell, and it wants to bring in another 4 in order to be full. And then nitrogen here is going to be -3. Oxygen is going to be -2, -1. So what's going to happen is you're going to get smaller, smaller, smaller until you get to this point, and then they're going to get huge, and then they're going to start to get smaller again. So I have a graphic here that I think shows this really, really well. So as you go across, notice what's happening. Here's like, let's go back down here. Here's my energy level number 4 right here. Okay, so this is energy level number 1. Sorry about that. Here's my energy level number 1, 2, 3, 4. And this is just going across the periodic table, except we've got visual representation here. So look what happens to potassium. Potassium, in its atom form, is big, but when it goes to its ion form, it's small. Why? Because it loses an electron. Remember, loses a whole energy level. So that happens there, happens there. So all of these ones are positive. All of these ones will become positive, so they get smaller. Now look at what happens right here with arsenic. So arsenic goes from its normal form to a way bigger form. Why? Well, look at, it's become negative. So arsenic is one of those ones that can become negative. So it is going to gain 3 electrons, making its ion form way larger. And so then, but you see as you go down from left to right, they tend to continue to get smaller. Well, why is that? Because selenium only needs to gain 2. This one gained 3, and this one gained 1. So the more electrons you gain, the bigger you are. So the trend continues, but it just resets with ion size. All right, one more little thing I would like to show you guys, and that is the idea of ionization energies. Now, ionization energies work like this. If you look at magnesium, magnesium, like we just said, would like to lose 2 electrons, and that makes it a +2, right? So it'd like to lose those 2 electrons in its outer shell. Well, ionization energy is the energy needed to remove an electron. Now, you can remove electron number 1. That's called a first ionization energy. Or you can remove electron number 2. That's called a second ionization energy. Or 3, and so on. So third, fourth, right, fifth. Now, let's look at magnesium. What would we expect to happen? Well, we can see that magnesium, sitting right here, wants to lose 2 electrons. Remember, the electron configuration of magnesium is 1s2, 2s2, 2p6, 3s2. So it has the option of bringing on 3p6 to have a full 3. That would mean I have to bring on a whole 6 electrons, or it can just get rid of all of these and lose those 2 electrons that it had. So that's what it does. It says, I don't want those 2 electrons in that outer energy level number 3, because then I can go back and have a full energy level number 2. So what is that telling us? Well, it's telling us that 2 electrons, it's easy to remove 2 electrons. So the first and second ionization energy, and the energy to remove the first and the second one, is going to be low. But if I try to remove a third one, now I'm trying to break this full energy level it has, and I'm trying to remove another electron beyond the first two. So to get to remove that third electron, which would be to change this from 2s2 to 2p5, now it's unstable. To get rid of that third electron there is going to have an enormous amount of energy. So the jump from the second ionization energy to the third ionization energy is going to be really, really high because it simply doesn't want to lose a third one. It wants to lose two. Same thing with aluminum right here. We could look at that. Aluminum wants to lose 3, right? So it's going to be a positive 3. And so it has a really, really low first, second, and third ionization energy, but it won't have a low fourth. So all you have to do is look at the positive charges for ionization energies and know, is this all, because all of these in group 1 are positive 1, all these in group 2 are positive 2. Most of these, except for boron, are positive 3. A lot of, except for the nonmetals up here, you can assume that these are going to be positive 4. Right? So that is the ionization energies that you would expect to be fairly low, and then anything beyond that charge you would expect to be high. So for aluminum, the jump from the third to the fourth ionization energy would be high. For for this one right here, for tin, the jump from the fourth to the fifth ionization energy would be really, really high. And so that's how you decipher ionization energies, knowing how the periodic table works and knowing how charges work and knowing how charges are changing the size of atoms and knowing how charges affect ionization energies and electronegativities and all those kinds of things. So I hope this helps you guys with your tests and all your chemistry needs. So remember, just to recap real fast, there's 2 trends. As I go from left to right, the atom gets smaller. The charges of the positive charges get greater and greater and greater and greater as I go from left to right. But the energy level stays the same, meaning that the electrons cannot go any further away. So it pulls on them harder. So that makes the atom smaller. It makes it harder to remove electrons. It makes the attraction for electrons greater. That's what those things are. And as I go down the group, I add more and more and more energy levels, which does what? Well, it makes the atom bigger, right? The amount of energy needed to remove electrons gets less because they're so far away, and its attraction for electrons gets less because it's so far away. So those are the 2 things, and knowing those 2 things, and knowing what electrons do in that way is going to answer a lot of questions for you. So I hope this helps.